Okay, so on page 7, we start this mean value theorem for integrals. Have we ever talked about mean value theorem before? Yep, lots of times, including just a few minutes ago. So mean value theorem for derivatives was where average rate of change equaled instantaneous rate of change. And I'm writing this off to the side because that's not what I'm going to talk about today. But just, it was basically where the estimation equaled the exact. Okay? The slope average over 2 points equaled the slope at exactly 1 point. That's what mean value theorem for derivatives means. Okay? What we're going to talk about today is what does it mean for integrals? All right, so we've got our conditions, continuous, closed interval, that's all the same stuff. There exists a number c in a closed interval. Okay, that sounds familiar. And then I get this equation right here. Okay, I want to skip to the picture, then we'll come back over here. How did we estimate, well, let me back up. Sorry. What does that right there mean?
Integrate and
What does that mean on the graph?
The area under the curve.
The area under the curve. Okay, it means this shape. So I'm going to follow the curve, and specifically between A and B. Okay, and A and B could be any numbers. So it means that area. All right, so how did we estimate this area before we knew to find it exactly? What Riemann sums. And what shape did most of our Riemann sums entail? Rectangle. Okay, so normally we had lots of rectangles, and we found that the more rectangles we had, the more close to that accurate answer our estimate was. Okay, what this theorem is going to tell us is that there is just some single rectangle, and I'm kind of drawing it just a little bit off so you can see how I'm shading this, but there's like a perfect Riemann sum rectangle, just a single one, where the area of the rectangle is the same as the area under the curve. Okay, that's guaranteed to happen when you have a continuous function on a closed interval, just like how this was guaranteed. A rock was guaranteed to equal I rock. All right, so let's see, like, what does this part of the formula mean? All right, so the base. If we start at A and end at B, how would you figure out how wide this is? B minus A. Okay, it's like if you start at 1 and end at 10, you would just subtract them to get 9. B minus A. That's the width of that rectangle. The height is going to come from finding this magical height, okay, that is perfectly excuse me, equal to the exact area under the curve, according to the integral. And we use this. We use f of c. If c is the magical place where this happens, f of c is the y value. Okay, so I want you to go ahead and write this off to the side, or y value. Okay, and that is the height. So together, they make the area of a rectangle, and you could put Riemann sum there. If you want to write it out, write it out. RS, though, means Riemann sum. Just abbreviate it. All right, so if you really get the old mean value theorem, I think this helps explain this. Now, this week is not the week to memorize this formula. This is the week to learn how to use this formula and to learn what it means. I don't want you spending time memorizing this formula, though. Okay? That includes the test. This test this Friday. We'll have another test eventually, and I will stop giving you the formula. We will worry about that starting next week. So here I kind of give you in other words here. All right, let's get down to the example. All right, so just using this formula, we need to identify these things in the problem, because it says find the value of c guaranteed by the mean value theorem. Well, here's my f of x. I know I'm going to need that right here. The a and the b should be given in the interval. And that's all I need. So we're going to do the integral from 1 to 3. I'm just plugging in 1 in for A, 3 in for B. The f of x should go next. And that's right here. Because I need to antiderive something, what's a better way to write 9 divided by x cubed? Yeah, we've been practicing this a lot. Writing it like a polynomial, 9x to the negative 3 power. Don't forget the dx. It's right there in the formula, so you shouldn't forget it. Okay, f of c. Don't make this harder than it is if f of x is 9 over x cubed, what is f of c? 9 over c cubed. Now you may be thinking, why did I rewrite it over here, but I didn't here? Well, on the left side, I know I need to antiderive, so rewriting it helps me. I'm not anti-deriving the right side, so it's fine to leave it like this. If you wanted to write it as 9c to the negative 3, that would be fine too. Okay, then I have this b minus a, so I'm going to put parentheses 3 minus 1. Okay, so that's the setup. Are there any questions about that, about the setup?
I'm a little confused where 9 over c cubed came from.
So if f of x is 9 over x cubed, f of c, you just plug a c right in over x. And so then I'd put a c there, and I'd replace that x with a c. That's okay. Good question. Somebody else was probably thinking it too. Good. Always ask. Okay, so the left-hand side, we can completely simplify down to a single number. If this is calculator stuff, let's use our calculator. But guess what? It's not. Or let's pretend that it's not, and let's do this by hand. Just for fun, you guys. Okay, so what's the antiderivative? Here, we have a 9. We put it over something. We write the x. The more you practice this, the more it'll get easier and easier. Add 1 to the power. What's that? Negative 2. Put that number in the denominator. We don't need a plus c because I have bounds that I'm about to plug in. Let's go ahead and finish simplifying this part, and then we'll worry about the right-hand side. Okay, so now I'm going to plug in the upper bound. I'm going to change this 9 over negative 2 to just negative 9/2. They mean the same thing. Plug in a 3, go minus parentheses, and then plug in the 1. This is a free response question. However, I know that I need to do something with this whole left side, so it's to my own advantage to go ahead and simplify. Okay, because I've got to solve for c, because that's what I'm looking for. All right, so I need to simplify this. It's really not that bad. What is 3 squared? 9. So what's 3 to the negative 2? 1 over 9. So guess what? That cancels with that 9. And so we're left with a negative 1/2 in the first group. Okay, what is 1 to any power? It's 1. That's why you're going to see 1 a lot, because it's easy to compute. So we have minus negative 9/2, so I'm just going to go plus 9/2, which is equal to 4. 8/2 or 4. Okay, so this whole left side is equal to 4. Okay, so I'm going to go over here and let's rewrite it. 4 equals 9 over c cubed times 3 minus 1, let's go ahead and just call that 2. And this is an equation to solve. So again, with a calculator, you should just use the solve feature in your home screen. Without a calculator, we got to use algebra skills. So we could do 9 times 2, but because 2 goes into 4 so evenly, let's divide by 2 and keep the numbers small. We're just trying to solve for c. It's just an equation we're trying to solve. So what next, algebraically? Multiply by c cubed. Divide by 2. So there are other ways we could have done this, gotten from here to here. But no matter what you do, you got to get that c cubed by itself. Mm-hmm. Why did I write equals 4 here? It's because I solved the whole left side.
You equal that.
Yep, the whole left side. I went over here and I simplified it down and I got 4. So I plugged 4 in for this. That definite integral you should always be able to solve down with a calculator or without. Okay, so let's go ahead and just get c by itself. It's just the cubed root of 9/2. It doesn't go down, it doesn't simplify. Don't try it, it doesn't help you. Even if it does simplify, it doesn't help you. You have to get c by itself, but beyond that, you don't really have to do anything else. So let me just kind of repeat the process so some of you are still writing down and letting it sink in. We used the formula. We plugged everything in. We solved the definite integral on the left and got 4. So I replaced that definite integral with 4. Then I used algebra skills to get c by itself. Now, this is my one and only answer, but it's worth it to just make sure that this falls inside your interval, which is 1 to 3. If it doesn't, then we did something wrong, because the mean value theorem for integral states that this should work. So you don't have to, you could use your calculator to get the decimal, but 9/2 is about 4.5, right? Okay, you don't know what the cubed root of 4.5 is, but what do you know the cubed root of?
8.
8. What's the cubed root of 8? 2. What else do you know the cubed root of?
1.
Think lower. 1 is 1. So this has to be between 1 and 2. It's that kind of stuff that can help you figure out if you got a wrong answer. It's not necessary to do the problem. Okay, and if this is not inside your interval, you did something wrong. Now there are times when you're going to get multiple answers, some of which are in the interval. Those are good. Some of which are not in the interval. We kick those out. We're going to do one like that in a minute. Okay, are there any other questions on this before we look at the next page? Okay, I would like everybody to turn to the next page, and I want you to just, before I even talk about it, I want you to look at this formula. So everybody's looking at this formula that I've circled up here in purple. I'm going to go back, but I want you to look at this formula. Okay. How do we go from the old formula, I don't want to say old, we just learned about it 5 minutes ago, to the new formula on the next page? Algebraically, what happened? Yeah, you got f of c by itself by dividing by b minus a. So on the next page, this may look totally brand new, but it's not. We just got f of c by itself. This is not something you have to memorize right now. It's going to be given to you, so you need to focus on how to use the formula and let it make sense. So remember that f of c, that magical height of that rectangle? That has its own name, and that is called average value. Have we talked about average value before? Yes. Skip all the way down to the second number 3. We'll just call this number 4. This problem right here, we already did problems like this with Riemann sums. So I'm going to bring it back full circle at the end. But for now, let's just recognize that we got f of c by itself by dividing by b minus a, and we got this new formula. So if the problem just asks for average value, what they are asking for is just f of c, not c. So let's use this formula here. 1 over, okay? Label your interval a and b if you need to. Maybe today, good. Eventually, maybe you can recognize that as a and b. So 1 over, what numbers would I write down here? Instead of b minus a, I would write 4 minus 1. Then I would do times the integral, again, a and b, so 1 to 4, f of x, that's right here, Copying down what I'm writing, great. That's the way you make sure your notes are right. But I want you to take a second and make sure you understand how to go from the formula to what we wrote down. Are there any questions about that?
So you know when to use this one versus the other one because this one says average value.
This one says average value. You do not have to memorize the formula this week. All right, so average value means f of c. Just to reiterate that, these formulas will be given to you. Okay, you need to know, though, that average value means just f of c, okay? All right, so I'm not working on both sides of the equation here. I just got to simplify this. If you have a calculator to do this, do it the easy way in the calculator. Of course, we're not, right? Because I'm mean. This one's really not that bad. What's the antiderivative of 3x squared? You should kind of start, I don't want to say memorizing these, but there's a lot of repetition here. 3x squared, antiderivative is x cubed, that comes up a lot. What about the antiderivative of 2x? X squared. Of course, if you didn't recognize it, you just do the same old antiderivative rules. Okay, I am not using plus c because I'm about to plug in the bounds. Okay, so I have 1/3. You plug in your 4. Y'all go ahead and try to finish this part on your own. If you need to look up at the board, please do so. Okay, are there any questions? Because that's good for a final answer. Now, because this could be multiple choice and because there's a second part of this problem, I want to go ahead and simplify. And this one's really not that bad to simplify. 4 cubed, that's 64. 4 squared, that's 16. What's 1 to any power? 1, and then minus another 1, that's 0. So we won't write anything. 64 minus 16, that's 48, and 1/3 of that is 16. So 16 would be what I want to use if this is multiple choice, or if I had to go further into a next step, which we are. Because there's another part to this problem. It says, and all values of x in the interval for which the function equals its average value. So remember, we found the average value. That's what we found down here, 16. So if I want to know where the function equals its average value, that's pretty much what I did on the previous example, although I don't need to go back and rehash out all the work. I just want to know where 3x squared minus 2x equals 16. I just need to solve that equation. The 3x squared minus 2x, that comes from the function. The 16 came from the average value. I'm just following the directions of the problem.
Why do you not put C for X?
Because I didn't put C in place of X. That would have been okay because it said find all values of X. If you had put C here, though, it would be fine. It would be okay either way. All right, with a calculator, I would suggest you use the solve feature, okay, in your home screen. We need to be prepared both ways. Okay, so if you're not used to using your calculator, you need to maybe do that. By hand, though, we know we solve all quadratics by getting everything on one side. Plan A is factoring. What's plan B? Quadratic formula. So I don't really want to spend class time on this. I'm going to go ahead and tell you that this factors into 3x plus 8 and x plus 2. If you're like, I don't know how to do that, you need to come in for tutoring. And I can help you one-on-one and we'll get it straightened out. But this does factor into that. So my two answers are x equals 8/3 and x equals -2. Okay, just like the last time, we need to double check something. Are these numbers in the interval 1, 4? At least one of them should be. That's what the theorem states should happen. 8/3 is, but -2 is not. -2 is not between 1 and 4. So it is like an extraneous solution. It's not an answer. Okay? All right, so that's how you kind of answer these mean value theorem, average value formula problems. All right, here's how this would look in a word problem. And it's actually not bad because generally, I don't want to say generally, almost all the time, these are calculator problems. So we're not going to do any of the nitty gritty math by hand. We need to be able to interpret, though, what to do. So Ryan is riding his bicycle on Katy Trail. For 0 to 40 minutes, Ryan's velocity is measured by this formula. Okay, that is the velocity. I'm kind of emphasizing that for a reason. T is measured in minutes, R of T is in meters per minute. Another good way I know that that's velocity. Based on this model, find Ryan's average velocity. So anytime you see the word average, we know it could mean average rate of change or average value. The way you know is, are you trying to average this thing? That's average value. Or are you trying to average this thing's rate of change? So since this is velocity and they're asking for average velocity, this is an average value problem. If they were asking for average acceleration given velocity, that's when we would do average rate of change. And I'm going to have to say this a lot. This is probably the most common thing students mess up in this class, and I get why. Because the same word means two different things. And you can tell when is which, but it's just going to take a lot of going over it. So this is average value. So I'm looking for that f of c. So I'm going to do 1 over, what's my a and my b in this problem? 0 and 40. So 40 minus 0. And then I'm going to integrate 0 to 40. We can't see it anymore, but I'm just using that formula up there. Then I'm going to write out the function. And I'm going to go ahead and use t's. If the t's bother you, feel free to write x's. It's really not a big deal. If you write the t's here, though, you need to write dt here. And so what I was saying earlier was the good thing about these word problems is you're going to get to use your calculator. Okay? And this would be really horrible to do by hand. All right? Really horrible. Especially if you had to simplify. Okay, so let's look in our calculator. So we can actually go ahead and do the 1 over 40 right there. And then go times. And then do the integral. Remember, the integral is f3, option 2. And you can use x's or t's. I'm going to go ahead and use t's. If you use t's, you got to do comma t, and then comma 0, comma 40. Okay, so I did it all in one go. If I press enter, it puts it in pretty print, so I can see that I've typed it in right. If you wanted a decimal, remember you're going to do diamond enter. It doesn't really matter which answer you put down. If you put the decimal down, though, make sure that you go to 3 decimal places, 333. If you leave off one of those 3s, you might as well have left it blank. All right, and that's in meters per minute. Okay? So the same thing with the calculator, a lot easier because we don't have to do all the integrating and plugging in and stuff. So that's one way a word problem could be average value based off an equation. This next one is actually review because it's a table and it's talking about Riemann sum. So here we have Riley, okay, who's also riding her bike, but instead of a function, we have a table. Okay, this gives us velocity, and it is asking us to estimate. That's a that's a key word that's kind of telling us, hey, maybe we're going to use Riemann sums, and we're trying to do average velocity. Since those are the exact same thing, this is an average value problem, not an average rate of change. And then it tells us the interval, A to B. It tells us which type of Riemann sum and how many. What are our subintervals? Yeah, so I'm going to do 1 over 40 minus 0 again. And if you don't like this 1 over 40, if you'd rather just divide by 40 at the end, that's okay too. Okay, that's not how the formula is written up, but that's essentially what we're doing, is we're dividing by 40 at the end. We're just putting it at the beginning instead. So I need to use trapezoids. So 300 plus 1900 over 2 times what? 10. Okay, and then you do another trapezoid, you do another trapezoid, you do another trapezoid. So 1900 plus 10. And so you really should not need to be looking up here to figure out how to do this. You should be able to do this without. Sorry. I'm going to skip to the next line. Remember, for trapezoids, you add them up, you divide by 2 because you're averaging them. Then you multiply by the time elapsed. Do you have to simplify this? No, we did. I'm kind of running out of room here. We did, but you don't have to anymore. Put your units on there and call it a day. If you're just dying to know what this is simplified, give me just 1 minute. I know some of you, you're not going to be able to sleep at night. I believe it is 20,600. If anybody wants to check that, that would be appreciated. All right, but you don't have to simplify it. Even when you get your calculator, you don't have to simplify it. You believe me?